Now let's suppose you want to find area between polar curves. How do we do that? Well, here's how we're going to do it. So say you want to find the area of the regions bounded by these two curves. Let's go ahead and sketch them. So here's our Cartesian plane, and we're going to sketch these. Again, if you need more help on sketching polar curves, I'll leave the related videos in the description box so you can check them out. So this curve right here, r equals 2 cosine theta. That's the circle that's along the positive x-axis. So when theta is 0, you're going to have cosine of 0, which is 1. So 1 times 2, that would be 2. So that's the point for when theta is 0. And then it's just a circle going around like this, passing through 0, 0 as well. So that's the circle r cosine, r equals 2 cosine theta. And for the second one, this is also a circle, but now that's along the positive y-axis. So when theta is pi over 2, you have sine of pi over 2, that's 1. So 2 times 1 is 2. So that circle, it's going to be at pi over 2, it's going to be up here. And then it'll create a circle like this along the positive y-axis. And we're interested in the area bounded by these two curves. So this is r equals 2 sine theta. So we want to know what is this area right here. So I'm going to shade it in a little bit later, but we got the idea which area we're looking for. Now let's find how do we compute that area. So this area will start from here, and we're going to add up all of these sectors all the way up to here. So that's what we're looking for. So first thing you want to do is draw this line and find where the two curves intersect. So the way we're going to do that, we're going to set both of these equal to each other. So for the intersection, we're going to set the two curves equal to each other. We set 2 cosine theta equals 2 sine theta. And this would mean that we have cosine theta equals sine theta. Well, we know that happens when theta is pi over 4. So this angle is pi over 4. That's when these two functions are equal to each other. So the way we're going to integrate this is in the following way. So I'm going to zoom in a little bit so you can see it better. So first, we're going to find the area by creating sectors starting from the origin like this. So we're going to find the area of that region, which has the curve r sine theta. And then we're going to add up the area of this region right here. So that's the region bounded by the 2 cosine curve. So the area we're after is the region that's shaded in pink and the one shaded in orange. So the one in pink is going to be the integral from 0 to pi over 4 of 1/2 r squared. So the one in pink, the curve that surrounds that area is the one in blue. So that would be 2 sine theta squared d theta plus the area in orange. So that's going to be the curve bounded by 2 cosine theta. So that's going to start from pi over 4. So here's right here, the orange curve starts at pi over 4, and it goes all the way around to pi over 2. So the integration for the orange region, it's going to be pi over 4 all the way to pi over 2 of 1/2 r squared. R, that's going to be 2 cosine theta d theta. So if you sum these up, you get the area of that entire shaded region. Now let's go ahead and proceed with the integration. So that's not so difficult. Now I'm going to show you directly first, and then I'll also show you, since the region is symmetric, we can use symmetry to actually integrate this. So let's finish up the integration. So this would be, pull out the 1/2. We have the integral from 0 to pi over 4, 2 sine squared theta, that's 4 sine squared theta. So this is 4 sine squared theta d theta plus the second one. I forgot to put a square here. We have 1/2 the integral from pi over 4 to pi over 2 of 4 cosine squared theta d theta. Now here we're going to use the identities. So we know that sine squared theta is 1/2 1 minus cosine 2 theta. So that's what I'm going to replace right here. And for the second integral, we're going to replace cosine squared theta with 1/2 1 plus cosine 2 theta. So this is where I'm going to replace right here. So our integral then becomes, so 1/2 and the 4, I can simplify that as well going along. So this would be 2 integral from 0 to pi over 4. So sine squared that I'm replacing with that identity, 1/2 1 minus cosine 2 theta d theta plus, and then the second one I'm replacing it with, so again, I'm going to simplify these guys right here. So that would be a 2 integral from pi over 4 to pi over 2 of 1/2 1 plus cosine 2 theta d theta. And then carrying along, this would give us, so again, more simplification, these can cancel. So you'll have integral of 1 respect to theta, that's theta, minus integral of cosine 2 theta, that would be sine 2 theta over 2. And we're going to take it from 0 to pi over 4. For the second piece, we're going to do the same thing. So again, I'm going to simplify these so they cancel. Integral of 1, that's going to be just theta. And integral of cosine, that's going to be sine 2 theta over 2. We're going to take this from pi over 4 to pi over 2. And now plugging in the upper limit of integration and lower limit. So for the first group, we have pi over 4 minus sine of 2 pi times pi over 4. That's going to be a sine of pi over 2. Sine of pi over 2 is 1. So this is 1/2. Plus, now when you plug, let's plug in the lower limit of integration. When you plug in 0 into both of these, they're going to disappear. So this is minus 0. And then for the second group, we have plugging in pi over 2 first. So theta will be replaced with pi over 2 plus, now for this term right here, when you plug in pi over 2, it'll be sine of pi. Sine of pi is 0, so you're going to get plus 0. And then we plug in pi over 4, so minus pi over 4. Now when I plug in pi over 4 in here, I get sine of pi over 2. Sine of pi over 2 is 1, so this would be minus 1/2. All right, now we can drop the parentheses. These are not needed. So combining like terms. So this one and this one, they will cancel. So what I'm left with is pi over 2, and then 1, negative 1/2 and negative 1/2, that's negative 1. So there you go. That's the area of this particular region. Now let me show you how to use symmetry to find the area. So of the same region, so using symmetry, since the region is symmetric about pi over 4, so if you look at the region, if you just integrate the lower half right here, just the lower half from 0 to pi over 4, and double that, you're actually going to get the same area as the above. So if you just take the pink integral right here and double it, you're going to get the same area as we just obtained by doing the entire integral directly. So I'm going to go ahead and using symmetry, the area is going to be 2 times the integral from 0 to pi over 4 of 1/2 of 2 sine theta squared d theta. So that's the pink integral right here, this one. I'm just doubling that. So if I double that, this is what I get. So this is equal to, again, replacing with the identity, you'll have, so the 2.5 cancels out. So you'll have just the integral from 0 to pi over 4 of 4 sine squared theta d theta. And we know what that is. So this is simply the integral from 0 to pi over 4 times 4 times 1/2 1 minus cosine 2 theta d theta. And then 1/2 and 4, that will turn into a 2. We're integrating from 0 to pi over 4 of 1 minus cosine 2 theta, d theta. And this would give us 2 times integral of theta 1 with respect to theta is theta minus integral cosine of 2 theta. That's sine 2 theta over 2. We're going to take it from 0 to pi over 4. Then plug in the upper limit and lower limit of integration. We have 2 times theta equals pi over 4 minus sine of 2 times pi over 4. That's pi over 2. So that's 1/2. And then when you plug in 0, you get 0. So all of this will simplify to simply pi over 2 minus 1. So the same thing that we got by doing directly. By using symmetry, sometimes it saves you a lot of time. So it's another way to do it. Right, here's another problem we're going to work out. We're going to find the area inside this region. So this is a circle, and outside this region, which is cardioid. So this is a circle, and this is a cardioid. So let's sketch them so we know exactly where to integrate. So here's our XY plane, and we want to draw this r equals 3 sine theta. So when theta is pi over 2, sine is 1, so that's going to be at 3. So let's suppose that's the maximum point, and then this is just a circle going around like this. So something like that. So that's your curve, r equals 3 sine theta. And then for the second one, we are going to be drawing this cardioid. So when theta equals 0, sine of 0 is 0. So this is at 1. So let's suppose this is 1. And then when theta is pi over 2, sine of pi over 2 is 1. So 1 plus 1 is 2. Let's suppose this is 2. And then when theta is pi, sine of pi is 0. So it's going to be at 1. So it'll look something like this. And then for 3 pi over 2 sine is -1. So 1 plus -1, that's going to be 0. And then for 2 pi, this is going to be back to 1. So that's the picture. So this is r equals 1 plus sine theta. So we're looking for the region inside the circle and outside the cardioid. So we're looking at this region right here. So that's the region we want to find the area of. Well, first of all, we need to find this intersection. So where to start this region, and also this point right here, where to end the region. Now this is also we can use symmetry because the region is symmetric about the y-axis. So this angle, well, let's find this angle. So this is where we're going to find the intersection of the two equations. So if I set them equal, I have 3 sine theta is equal to 1 plus sine theta. Subtract sine theta from both sides. You have 2 sine theta is equal to 1, which means sine theta is equal to 1/2. And we know when theta is pi over 6, sine theta is 1/2 in the first quadrant. So this angle is pi over 6, which means on the second quadrant, this is 5 pi over 6. So now we know where to integrate this. It's going to be the integral from, so we're going to find the area of the entire circle first. And then that's gonna give us the area of this entire piece. And then we're gonna subtract away the area from the cardioid bounded between pi over 6 and 5 pi over 6. Hopefully you got the idea. So check this out. This is what we're gonna do, because that will give us the area what we want. So if I integrate from 0 to pi of the circle, so this is 1/2, the circle has the equation 3 sine theta squared d theta. And I take away the area of the cardioid, which will start from pi over 6 all the way to 5 pi over 6, because that's where it starts and it ends right here. and integrate 1/2 of r squared of that. So this is 1 plus sine theta squared d theta. That gives me exactly what I want. So this will give me that region. Now we're going to use symmetry because the region is symmetric. So I can look at the first integral. So using symmetry, we can integrate the first piece from 0 to pi over 2. So if I only integrate this right here, and I can double it, that gives me the other half. So we're using symmetry again. So this will be 0 to pi over 2 of 2 times 1/2 3 sine theta squared d theta, minus, also using the symmetry for the second region, it will have, again, 2 times the integral. So now I'm using symmetry, so I'm only going to integrate from here to here. So not just that, just this right here. So from pi over 6 to pi over 2. So using that idea, this is going to integrate from pi over 6 to pi over 2, double of that integral. So 1/2 1 plus sine theta squared d theta. That'll save you a lot of time. So this is what we're going to proceed with. Well, let's go ahead and continue. Simplify before we integrate. Simplify that, and expand. We're going to use the same identity from before. So this is equal to the integral from 0 to pi over 2, 9 sine squared theta d theta. Well, we know what sine squared theta is, so I'm going to replace it here. This is 9 times 1/2, 1 minus cosine 2 theta d theta, minus the 2.5 cancels for the second integral. We're taking it from pi over 6 to pi over 2 of 1 plus sine theta squared. So that would be 1 plus 2 sine theta plus sine squared theta d theta. Okay, so I'm going to replace this with the identity 1/2 1 minus cosine 2 theta. And let's go ahead and integrate. So for the first integral, we have 9 over 2 theta minus 9 over 4 sine 2 theta. And we're going to evaluate this from 0 to pi over 2. The second piece, now before I integrate, I'm going to distribute these. So I'm going to rewrite that one more time. So this is minus the integral from pi over 6 to pi over 2 of 1 plus 2 sine theta plus 1/2 minus 1/2 cosine 2 theta d theta. Now here I want to combine these guys. So 1 and a 1/2. So this will give us 3/2. And then the next term, we can just bring it closer. So here's what this simplifies to. This is what we're going to integrate now. So for the first two terms, I'm going to rewrite these so I don't have to be keep writing them. So here's the first part. We'll evaluate a little bit later. The second part, so we have minus all of these guys. So 3/2 theta, integral of sine. Well, that's going to give us a negative cosine. So this is 2 negative cosine theta. And then for cosine 2 theta, we will have 1/4 sine 2 theta. All right, so doing this very carefully, we're going to evaluate this from pi over 6 to pi over 2. Okay, so now let's plug in the upper limit of integration for the first group of parentheses. So you'll have 9 over 2 times pi over 2 minus 9 over 4 times sine of 2 times pi over 2, that's sine of pi. So it's going to be 0. So this term is going to be 0. Minus, now when you plug in the lower limit 0 into each theta, it's going to go to 0. Minus, now for the second group of terms, 3 over 2 times theta. Theta is pi over 2 for the first, minus 2 times cosine of pi over 2. Cosine of pi over 2 is 0. So we can highlight this one. This is going to be 0. and then minus 1/4 sine of 2 times pi over 2, which becomes sine of pi. So that will also go to 0. So I'm just going to highlight that. Now let's plug in the lower limit of integration. So we have minus 3 over 2 times pi over 6. And then minus, that's going to be a plus 2 cosine of pi over 6. And then minus, that's plus 1/4 sine of 2 times pi over 6, that's pi over 3. All right, so all of that inside the parentheses. So now I'm going to go ahead and distribute this negative in the front. So this will clear things up a little bit more. So that's negative. This is going to be positive. It's going to be 0 anyway, so 0. Positive, this is also 0. This is positive. This is negative. And this one is going to be negative. So it's a very long problem, but we just have to be very careful. Let's see what survives. So we have 9 pi over 4. And then we have minus 3 pi over 4. And then we have plus 3 pi over 6 times, so that's 12. So I can say this is just pi over 4. And then minus 2 times cosine of pi over 3, that's going to be a square root of 3 over 2. And then minus 1/4 sine of pi over 3, that's also square root of 3 over 2. So if you combine all of these, so this would be, these are like terms. So that's negative 3 pi and 1 pi, that's negative 2 pi, that's 7 pi over 4 minus, now here I'm going to get negative 2 radical 3 over 2, and then so I can simplify these a little bit. So you have square root of 3 minus a square root of 3 over 8, which is really just 9 square root of 3 over 8. All right, so there you go. That's the area of this particular region. So yeah, it's a very long problem, but just be very careful on when you do these computations. All right, so I'll see you next time.